our subject matter at hand is life cycle of the building, as in terms of the building biologists, we always say how big the scope of a building should be when we are discussing the building at hand. Sustainability is a concept that we all know, are familiar with, and of course we know how wide of a concept it is, followed by resilience, and we were trying to tackle it with the panel members. What is sustainability? So when we try to explain what sustainability to the awareness that we have about the environment, and there is a beautiful definition that I have found so far. Sustainable design is trying to find out how the living continue to survive without hurting, damaging the environment they live in order to provide the continuity of their species. And this is something that we have to also remind ourselves about the work when we are designing a process. Since I am an architect by training, I will try to explain it in full. So what do we do? What you do see here is a forest of small houses surrounding a forest, and that's what we imagine. And when we dream about this, and we always design it and imagine it within this world. So as a society, since we are so much oppressed, so we feel like as if we are environment friendly, and when we try to also respond to that with the design, it requires a holistic approach. Of course, there is a process design. It's design, it's building, it's construction of a building, its impact, and its ecological impact, and its social impact have to be also included in the process, and we have to know it in the beginning. That's why we have to have a multidisciplinary approach, bringing sociology and philosophy, and we have to see it as a prioritized one, prioritize this principle, and we have to tackle the subject like that. So there's the phase of a project in the process of its implementation, how we design it. So why do we build a school here? We build a school so that people can come and be educated, which is followed by a design and scenario phase. In the B and C, we have architects and also urban planners step in, and then it's implemented, and then it's constructed, and then it is put into use. That's where the actual life starts. So if we don't know what the building will serve for in the beginning, there will be a high probability of making mistakes in the B and C stage. So we have to understand what the goal is, what the goal is for that building, or what the social impact will be. As the building actors, our jobs will be easier if we know that. Therefore, we have the social engineering impact, and today, with the management of our perception, we can just try to sell this building to people as if it's a green building, and we can also serve it, and we can also become really successful with that. So people think that they are living in an ecological structure when they are able to have plants in their balconies, and it can be easily imposed on them. About the life cycle, and we need to discuss that issue as well. About the life cycle issue, the matter at hand, the energy that is used in the construction of the buildings, because that's where the biggest share lies. Of course, if we need to make a comparison, a simple comparison of the material used in the window frames, and also if you compare the amount of energy used in the production of these materials, the first one is wood, the second is plastic, the third one is aluminum, and the fourth one is a combination of wood and plastic. So as an architect, we have to also, in terms of the carbon footprint and also its life cycle, and we can do that for all buildings. This is a cycle that you all know of, how the raw material is extracted and how the acquisition takes place. Then it's turned into a material using energy, turned into manufacturing. We use it, and at the end of its life, we're talking about a 60-year period of time in buildings. So in Japan, they knock it down in the 61st year because the material is old. And after using it for 60 years, and we also come to a possible phase of disposal, are we able to recycle it, or should we dispose it as it is? So only the time frame of 60 years for its use, what kind of an impact does it have when we use it? It has a direct impact on human health. It has a direct impact on the environment, and also it has a social impact on the society, and also it needs the building sector because of the renovations and upgrades during the time it's used. Considering the life cycle of a building, this is only a small part of it. So we cannot just limit it to the 60 years, and we're not in a position where we are able to just limit it with the 60 years. As I mentioned earlier, this part, the period which covers from the raw materials extraction and also how the material is used, requires a lot of energy, and we have to minimize this energy as well. And the calculations saw that this, if we can, recycling does not actually cause any kind of a environmentalist impact as its original terms, because there's a huge so there is a mitigation zone, and this area is the point where we are coming to a bottleneck in the life cycle phase of the one. So in order to just tell you how much of a consumption we have, it can be any kind of building, could be a school, a place where you live, and we need this kind of building, and we have to also make a decision. And our goal is to build a sustainable building, to be able to build a sustainable structure. So I'm just going to use the window frames as an example, and if considering this kind of impact through the perspective of the window frame, this is where it starts. So we start to consume energy and consume also resources. So while we do that, we are going to also extract natural materials. We have teams, we have used energy, we have used resources. So it could be fuel, could be fossil fuels, could be solar power, could be wind, just to be able to extract the raw material from its actual origin. And there is this also scenario of the manufacturing of the material. There is also the other sector of transportation. Whether it's coming from a quarry or a forest, it needs to be transferred to the actual place of manufacturing. So you have to also include all the other different parts and elements of transportation. So we are just approaching to the manufacturing of the aluminum window frames. There's also another sector of transportation. Let's say that we have extracted aluminum and also managed to carry it to the place where it's going to be produced into a product. And let's say that we have chosen the material and the construction phase has started, as you can see, after completing this construction phase. So we have our window frame, the aluminum window frame. Actually, there's so much of energy consumption and there are so many sectors, business sectors in the background. So we see a major difference between choosing a window frame made out of aluminum that is in consumption of high resources, or another type of window frame that uses low resources. There's a big difference. It goes for climatization, electrical infrastructure, ventilation, for all the other elements, and also the furniture industry that has been involved in choosing the furniture for that particular building, and it all comes down to one house, nothing else. A house that is going to host and accommodate us for a period of 60 years at its maximum level. So the building material that we have chosen matter, and it becomes a huge factor depending on what we choose. So we can also provide energy and also save energy by choosing the right material, and we can also save energy by choosing the actual type of production, and it also is embedded in the energy that is consumed in the production of that material. So that's what is the main issue is at hand. So let's talk it through the means of the single building. This is in Kadıovacık biohouse. All those approach that I have tried to explain here was implemented here so that it can become a reality. We called it Kadıovacık biohouse. So we wanted to establish a healthy structure, on-site and suitable design, environment-friendly with proper material. And on the issue of human and environmental health, we have chosen the interior elements and the interior walls and the framework and the floor covers and the flooring. And we decided to choose the material. Although it's not difficult, it's not easy to read the building as it is. When you look at it from outside, the actual main carrying system, the system that carries the roof within the building, is chosen specifically based on the material that is produced and manufactured using less resources. For the very first time, Metsim company has carried out a carbon footprint of this building, and Metsim Sustainability Consulting used the data provided to it and also has established these categories using the internationally approved rules. So it has a floor plan of 226 meters square, and its carbon footprint is about 121 tons of carbon dioxide, and has 535 kilograms of carbon dioxide per meter square in the gross meter square percentile. So when you compare it to the other examples from abroad, from Europe, which are comparing it to the other environment-friendly buildings, these values are almost half as much as the other environment-friendly, so-called environment-friendly buildings. So the foundation is made out of a concrete foundation. It's the official building. In order to make sure that we have a building license, we have to just use this kind of material in the foundation of this building. So we try to also create a carbon footprint distribution of the basic building units. So 79% of the carbon footprint lies in the foundation. The roof, which is made out of wood and adobe, provides 8% of the carbon footprint. The outer facade has a 6% share in the carbon dioxide footprint. And as you can see, the 79% of the carbon footprint comes from the foundation, and which makes the big difference. And we wanted to also show you it is in simplest terms in the visual manner. The foundation only constitutes 17% of the actual structure. The rest of the structure, the upper part of the building, consists 83% of the whole structure. But the foundations cause 79% of the carbon footprint. And the upper structure, which is made out of wood and adobe, because it's made using these materials, only has a share of 21% of the carbon footprint. If we had built the building with an actual concrete structure, the numbers would seriously change in a complete different direction. Also, thanks to the photovoltaic energy generation system installed in the roof, will also allow us to diminish and mitigate the carbon footprint, which we were only able to install 2 years after the building had been built. This is the first of its kind. The total carbon footprint is half as much as a regular house in Europe. So we have a solar energy GES integration allowed us to pay it back to the grid, and we can also provide a lot of savings, and you deduct it from the carbon emissions, we have a carbon surplus. So it's a basic building built with 80% of natural construction materials, and I'll follow from there, trying to give you more information about the inner world of this building. You have a wooden structure. The insulation material is the wheat. It could have been a rock wool or some other common construction material. The heat insulation value and the performance values are the same, but the glass wool and the rock wool has a huge impact on human health, and in terms of the energy used in the actual production of these materials, the weed insulation material is far off the charts actually. So, and this is actually material that we can produce, and it's not chemically treated. It's as simply just bound together with a simple wire, and it's the easiest material you use. So it's also legally acknowledged in Germany because of the norms provided by religion and DIN norms as well. And the adobe on one side have high heat storage capacity. And what is more important here, adobe material, adobe bricks require very few, small amount of energy in its actual production. Since it's prepared in an oven, the life cycle also is extended, and also the plaster is that is used in the interior walls require earthenware material. So we first we tried our best efforts to make sure that the acclimatization of the building will be an active manner, so that we would refrain from any kind of climatization, so that we wouldn't need any kind of air conditioning systems. So with the cross ventilation, so we allow the rising warm air to be discharged off the house, thanks to the structure of the adobe brick buildings by creating shadows. And we try to make sure that the summer sun rays are in contact with the interior walls to prevent the heating of the building. And in winter, for heating, so you can also see it as the resistance system that you would install on the back window of your car. And the wires are also installed in the back of the earthenware covered plaster. So we have installed them by opening channel, carving out channels, and the adobe brick wall that has been covered with earthenware plaster, and it requires a very simple touch screen, allows you to control the system in general. So the energy generated off the solar photovoltaic cells are actually stored to keep the walls warm during winter. And here is what we have done. The mass heat acquired through summer is used in fall. And the red screen shows you the temperature in summer, because in summer this temperature may go up to 35 degrees centigrade, and in fall, in autumn, this temperature of the walls will start to continue go lower. And usually, considering the geographical conditions of this area, it may be in September, October, never late as in November, when we realize the wall temperature is up to 20, 21 degrees centigrade. We use this touch screen to adjust it, to make sure it goes up to 22. So until the next spring, we keep the walls as warm as that. So the building is never heated from zero, ground level. We always use the summer mass heat and the summer mass temperature of the building, so that it will be heated at a higher temperature. No other material will provide you that, except for the adobe brick that is used. It just heats up slowly and it cools off very slowly. So it's usually used for buildings that are used when you live on a regular basis. So it's not the right solution if you're going to your summer house and you cannot heat your summer house right away.
So this is, again, an example for passive acclimatization. This cross systems, and there are windows which are open throughout the year. So we have windows above and below where the direct sunlight is let in. And during summer months, for example, the windows below are shuttered down. The shutters are closed, so the interior is enlightened sufficiently in a natural way. And lastly, again about this building, a couple of images from the interior. These are again mud surfaces, and we have wooden floor tilings. Of course, you should not place cupboards in front of it. It should be open, so that it is very much about the natural heating that comes up, so that it could be acclimatized appropriately during summer and winter seasons. A number of other images from the building, and I think this is the last one from the terrace. Again, this area is used during summer, and reeds are used to create some shadowy areas. And again, it's all about making use of the sunlight in a natural way. We want the sunbeams to come through these reeds. So depending on the season, the terraces are kept open or closed. And lastly, let us share a number of other examples from the world. And then I will be moving on to the panel. Of course, there are some other studies that have been carried out. One of them is in Turkey, Gökçeber village on the peninsula of in the Mula province. Of course, it's difficult to read out the figures from there, but the presentations will be shared with you. So again, based on a life cycle analysis, it is shown amongst the best practices around the world. Another example from Germany, in Rosenheim, another structure. Again, it's made of mud brick. And this is the floor tilings. Bricks are used, and then it's again a mud brick structure. We have the insulation and ventilation systems mentioned previously. This is the Causa publishing house. I think it was published. It was established 3 years ago, and they have published a book in Switzerland about buildings as such. So they have 21 examples chosen from the world, from different parts of the world. So the IBN Institute is in this book as well. This is the Herba farm. It's a very simple structure, but actually it's the very reason why it has been selected for this book, just because of its simplicity. So that means we don't have to think in complex terms all the time. This is the last slide, again from Germany. This is a selection made by the Ministry of Environment, again from 2013, a wooden structure. And again, the figures and values are on the slide. So, well, we have many other data and figurative pieces of information which could be diversified, and you can collect more and more data. But instead of dancing along with numbers all the time, today I would like to focus more on principles and on a holistic perspective. This was what I have tried to do. What do we really mean when we say sustainability, and what it means to raise awareness in issues of environment and acclimatization systems and so on. But we are responsible for the energy consumed to produce these green materials as well. That means we really need to have a holistic approach and think the backdrop of things as well. We have 3 minutes left, and I would like to thank you for listening. And if you have any questions, we can have 1 or 2 questions during these last 3 minutes, and then we will move on with the panel. Yes, please. Well, thank you for your presentation and for the valuable information you have furnished us with. I have 2 questions. I mean, you talked about reeds and other sorts of materials that you have used or which have been used, and I think you have also talked about hay and how that material is used. So, do you have any problems when you are trying to issue construction permits or zoning permits because you're using different materials? And secondly, you talked about keeping the walls warm. So if you have underground water sources, why have you chosen walls to create warmth? Well, we don't have any issues with legislations and permits, because what they look essentially is the foundation and the how the building stands. So we have 3 options. It's mud, soil, concrete, or steel. So wooden constructs are our priority. We use them as a bearing system. But even if we would have to use concrete as a conveyor or as a load-bearing system, it's not a great issue, because when we use concrete in the carrier systems, in the conveyor systems, we are talking about like 15 or 20% of the building, and you can ignore this 20%, and you can still use natural materials for the remaining 80% of the building. So they don't have any issues with that, actually. This is what I'm trying to say. And in the zoning permits, you are asked to provide the authorities with a heat insulation system. And the most important thing for you is to use materials which are registered, because in Turkey, heat insulation systems are produced with materials like hay, reed, and rubber, and many other natural materials. And hemp is also used among many others. So, for example, we have rolled out a project and delivered the papers related to it, and they have asked me what that is all about, and they have asked the physical value, I mean, how much that would cost. So they have just looked at the list and signed it. So it's a process of transition in Turkey, if you like. So natural construction materials will be part of the legislations gradually. Floor heating systems, yeah. The floor heating, that might be an option, but from below to top, it heats up the air. And since the air is coming through the windows, and it enables the particles in the air to rotate in mid-air. So underfloor heating is not the best solution we have for our challenges, because when you use it and disseminate it on larger surfaces like the floor, like the walls, instead of the floors, because on the wall the temperature is rising above 23 centigrade degrees, for example. So that should be made use of. So this was the Q&A session. Thank you for your questions.